Hi all. In this video, we're gonna discuss about Crew AI based design patterns implementations. So first, we're gonna install Crew AI, and then we're gonna configure the API key. I used Grok API key. So we're gonna discuss about the augmented LLM. Basically, it forces the model to delegate all the arithmetic to explicit Python tools guaranteeing numeric correctness. So here the tools which we are going to use are multiply and divide, which are declared with at the rate tool annotation. Therefore, the type signatures let CrewAI handle JSON type argument encoding, and whereas the tool cal agent binds those tools and is hardwired by the system prompt to never calculate mentally, and then evaluate expression passes the user's variable expression and processes sequentially plus max rounds. We have set it to 4, means the agent receives the expression and then it emits a multiply or divide call, and then the crew executes the call and returns results as tool output, and the loop repeats until agent responds with the plain numeric answer or the limit is hit, and the end state shows only the final numerical value, which is deterministic and auditable. Here 8 by 4, 8 into 4 is 32, and 100 by 5 is 20, and 10 by 2 is basically 5 into 3, which is 15. Moving on to next pattern, which is prompt chaining. So for all this pattern demonstration, I used DeepSeek 70 billion model, which is a digital model available in Grok Cloud. So this pattern focuses on fixed stages of pipelines. Therefore, therefore it extracts insights and then rewrites as polished paragraph. So here, insight agent uses a narrow prompt to output exactly 3 bullet points, and whereas the writer agent takes those bullets and then expands them into statements. And moving on to task 1 and task 2 run sequentially, and Crew AI stores the task 1 output and makes it available to task 2, and the result is going to be a paragraph. Only two model calls are used here. So this is the output. And moving on to parallelization. So the concept behind this pattern is to run independent content generators concurrently and then merge them. So here the asynchronous tasks are task summary, task analogy, task facts. All have asynchronous execution as is set as true. Therefore, crew dispatches all three parallel requests to the group cloud. And moving on to the merge phase, after all features resolve, the task merge handled by the merger agent concatenates the summary plus analogy plus fact into one paragraph. And then the execution time is kind of slowest single branch instead of the sum of three, because they are running parallelly. So after all three have executed parallelly, it the agent is going to merge and going to give the final result. And next, moving on to the routing, this is similar to dynamic branching. Therefore, it classifies the query and then let a specialist agent answer it. So here the router agent returns exactly one token, which is going to be the summary, analogy, or fun fact. And then the specialist, the three agents, wait with their own task, all run, but the script selects the output matching the router's label. Therefore, labels equal to classify task dot output dot raw dot strip. So cost optimization would skip unused tasks, but logic shows deterministic branch selection with minimal parsing. So this is the code and these are the results. And then moving on to orchestrator worker. It's basically plan, write, and then synthesize. So here a planner is orchestrator agent. which is instructed to create two sections. And then comes the worker agent, which uses template, write the section. Therefore, here it shows the single worker reused per section. And moving on to synthesize synthesizer. So the synthesizer agent merges headings and description into Markdown via combined sections. And then comes the flow control, which is custom Python helper function, which is generate report plan and write section, and then combines the section, which simulate CrewAI's output. So it has generated first the various sections and then it has merged finally. And moving on to evaluator optimizer. So it basically drafts the tweet, critiques it, and then it redos until the grade is good, or the retries which we have defined are exhausted. Here, the generator agent crafts the tweet, and whereas the evaluator agent replies with the text that includes good or bad, and the loop notebook checks if bad in feedback lower, then reruns the crew kickoff, and we have set the max rounds equal to 3 because of the computation costs involved. And moving on to traceability, for each iteration draft plus feedback can be logged for later quality review. So this is the initial tweet generated, and it has critiqued it and it finally graded it as A minus. And moving on to React agent. In simple terms, it's a kind of plan, act, and observe. So it does the iterative reasoning, which are generate, observe feedback, and adapt. Therefore, conceptual React build built on the same generator evaluator pair. So this evaluator feedback acts as an observation to become full React, which also bind real tools and lets a single agent alternatively emit tool calls and final answers, which are tagged inside one loop. So routing to decide between a simple prompt chain or a full orchestrator worker part, which then finishes with the evaluator optimizer, which is polished. And this is the output. Thank you.